This is part 5 of section 5.1. So let's quickly review what we've been saying is that in the past we were finding solutions. We'll just use this space up here to write this. Solutions to quadratic functions and other polynomials. Well, then we got into graphing and we were looking at intercepts, but we found them the same way. And now we're looking for zeros. It's just the context of the problem, but the procedures are the same. Okay. In example 5, we want to find the polynomial given certain zeros. So they're going to give us the zeros, tell us the degree of the polynomial, and what leading coefficient to use. So if -4 is a 0, what is the factor? Right, it would be x plus 4. So let's start writing our polynomial function. Our leading coefficient is 1, so I don't need to write 1 times. I know I have a factor of x minus -4, which would be x plus 4. I know I have a factor of x minus -2, or x plus 2. And I know I have a factor of x minus +3. So this is my polynomial function. Let's multiply that out and see what our we can tell right now our degree is going to be 3. You should be able to tell that, but let's just see. So I'm going to let the x plus 4 wait while I FOIL these two and get x squared minus 3 plus 2 minus x, and 2 times -3, -6. And now we'll multiply those out. X times x squared is x cubed, x times -x, -x squared, x times -6, -6x, 4 x squared, 4 times -x, -4x, 4 times -6, -24. Combining like terms, we get x cubed, -x squared, plus 4x squared is plus 3x squared. And then we have -6x and minus 4x, minus 10x, minus 24. This is a polynomial of degree 3 with the zeros of 4, -4, -2, and 3, and a leading coefficient of 1. If r is a 0 of a polynomial, and the exponent of the factor that produced the root is m, then we say that r has a multiplicity of m. So let's see what we mean by that. If r is a 0, in this case, do you see what the zeros are? Well, maybe these two are a little easier to see at first. The 0 here would be 3, right? And here, -2. And the exponent of the factor that produced the root, here's the factor that produced the root of 3, the exponent is 2, then we say that r of 3 has a multiplicity of 2. It occurs twice. They're just writing it more simply with an exponent, but we could write x minus 3 and another x minus 3, and so it occurs twice. So that's all this is saying. How many times does that particular factor occur? Now I skipped over this one. What 0 do we have here? Well, it's 0, isn't it? Yes, that indicates that one of the zeros, of the real zeros of this polynomial function, is 0. Okay, so find the x and y intercepts of the graph of f. That's what they asked us to do. So what are the x intercepts? Well, we said intercepts are zeros or solutions. We just said what the zeros are. We have the 0 of 0. We have the 0 of 3 and -2, right? X plus 2 equals 0, x equals -2. X minus 3 equals 0, x equals 3. X cubed or even -x cubed equals 0, x equals 0. All right, what about the y-intercept? How do you find the y-intercept? Let x equal 0, right? So in other words, if we let x equal 0, f of 0 equals -0 cubed, 0 minus 3 squared, 0 plus 2. But here we have 0 cubed, that's just 0 times all this stuff is just going to be 0. So the y-intercept is 0. For each x-intercept, determine whether it is of odd or even multiplicity. Well, let's list them. Let's list our X-intercepts. Another name for that is real zeros, or we've been calling just zeros. And then we'll list their multiplicity. That's a fancy word for just how many times does it occur. And then we'll tell if it's odd or even. So our X-intercepts, here's our list. 0, 3, -2. So 0, how many times does it occur? Well, we've got it x cubed, so it must be 3 times. That means x times x times x, and we're saying x is 0, so the multiplicity is 3, and 3 is an odd number. We're supposed to tell odd or even. 3 is odd. 3 occurs twice. Multiplicity of 2, that is an even number. And -2, well, no power here, of course, just means once, and that also is odd. Okay. Find the polynomial given zeros, multiplicities, and a point. Okay, so we're going to actually write what the polynomial looks like. Get this straight. They've given us the multiplicities for the zeros and a point on this function, polynomial function. So let's start with f of x equals. We don't know what the coefficient, the leading coefficient will be, so we'll call it a. Remember in this example, they said, no, just use a leading coefficient of 1, and we did. But here, so we could have just written 1 right there, and then end up with the same thing. But here they're not telling us that, so we better account for it could be something else. All right, we have a 0 of -1, that means the factor is x plus 1. With a multiplicity of 2, that means the power is 2. We have a 0 of 0, so that's not, what, x plus 0? Why would we write that? We're just going to call that x. With a multiplicity of 2, that means squared. I'm just putting these little dots here to show we're multiplying all this stuff, right? And finally, we have a 0 of 3, so the factor is x minus 3 with a multiplicity of 2. Okay, so now what we're supposed to do is ultimately write this whole polynomial out, but we do not know what a is. We do, however, have a point that is on this function. So we know that when x is 1, f of x is -48. So let's plug that in. So when f of x is -48, x is 1. So we have a. We don't know what a is, but that's the only thing we don't know. We'll have 1 plus 1 squared times 1 squared times 1 minus 3 squared. -48 equals a times 1 plus 1 is 2, so we've got 2 squared times 1 squared is just 1. I'm not going to write times 1. That we don't need that. And then 1 minus 3 is -2 squared. -48 is a times 2 squared is 4. -2 squared is also 4. -48 equals a times 16. Divide both sides by 16, and we get now the leading coefficient is -3. Sorry, we're having trouble seeing that. Let me see if I can fix it a little bit. All right, so our leading coefficient, now we know what that is. It is -3. So now we've got to write this thing out. What is our polynomial function? I'll do it over here. F of x equals -3 in all of this, but I don't like this x squared being there. I'm going to rearrange -3x squared times x plus 1 squared times x minus 3 squared. Let's get this all on here. There we go. Okay, so all I did was come back here, plug in my -3. I rearranged a little bit to make it look nicer. Okay, so now what we have, let's check it. This should be a polynomial function with zeros of -1, multiplicity 2, 0, multiplicity 2, and 3, multiplicity 2. And we already used the point to get a. That's what we needed that point for, was to get A. Okay, we will continue in our next video.